Today I'm going to teach you how to program in C language. This is an introduction, a kind of hello world, how to develop some basic program for people who start programming with it. Because I noticed something on the social network, many people choose to start with C programming as their first language. They have no knowledge of computer science. They have no knowledge of information sciences. They just go on a social network, and they ask a question. I want to start programming. What is the best language you suggest? Some people say learn C, and then they start learning C. But for sure, when you don't know nothing about computer science and you don't know nothing about information science, it could be a little hard. Sometimes you need a tutorial like that just to have to grab a couple of knowledge to start and understand a couple of things regarding C program, but also how the binary work or hexadecimal, or it doesn't matter. So that will be the purposes of this tutorial today. I chose to train from a Benin student who sent me some program where he asked me a couple of things. So I'm gonna use those example. I have two of them, and we're gonna go with the third one after. And I'm gonna teach you starting from that. And then you're gonna see that most of my programming, I do it on a Linux machine. But if you agree, if you like to learn Linux at the same time, you're gonna see a couple of commands I will type, and you may also learn a couple of basic Linux commands from that C programming tutorial. If you have Windows, don't worry. The C program I'm typing in, it's quite basic, and you can fill the same code in your preferred Windows compiler, and it will work because we are at the first level of C. It doesn't matter if it's Unix or Windows at this moment. That tutorial is also for you. And then we're gonna start with just for your information. You can see on my screen GCC. GCC stands for GNU C compiler. In fact, this is the compiler I'm going to use today. And GCC, it's a GNU C compiler. That kind of compiler, it's a free open source and free redistribution software under Linux, that it's also open source. Let's get to the command line now and start viewing these examples. I'm going to start with example number 1 here. I call my files example1.c. This is the code exactly how I got it from the Benin student. He have this code. I think he got it from a book or maybe somewhere else. I don't know. He received the code like that. He have some difficulties to understand that code, and it's hard to understand too. In my humble opinion, this code is not really well structured, so it make it hard to read and understand. So I'm going just to reformat the code just to make it more readable, in my opinion, because when you begin in C, you don't want everything like that. So don't hesitate to insert some space sometime. It could be more readable. You can also insert comment in your code. And those comments, sometimes it's helpful to understand what's going on in a code. So this is my first program. a comment start with /star and it ended by //, it doesn't matter what's in between. Here I can put Y. I can remove the star here. I can change that with %, as long as you start with /star and you end your commentary by /. So this is a comment. You just insert some comment sometime in your code, just to, when the function, it's not clear what the function does, you can put a comment. So if someone else goes in your code, or yourself, you reopen your code 3 months later, you'll remember what that program was doing. By the way, this is written in French. I'm going to translate that in English during the format, the reformatting of the view. So we declare an integer here. An integer, it's a number that like 1, 2, 3, 4, or 5. It's a full number like that. And then we're gonna send printf, mean a print formatted. So this is the instruction to send something on the screen to the user. And the format, we can put a format, but there is no format in this one actually. And then we're gonna print on the screen, please, or what is your here. So we're just asking for here, okay? And then the second instruction, scanf. Scanf mean we have to read something from the standard input. So that printf is going on the standard output. Standard output is usually the screen, okay? And standard input is usually the keyboard. So we're gonna read, we're gonna print on the screen, what is your here, the here you're looking for, and you're gonna read that here, and you're gonna put that in a variable called here. And then I put a space usually, because this is my variable declaration. Those two instructions are related because we print something, we have something to the user, and so we have to wait on the keyboard to get it. And then we're gonna process it. So here, I'm gonna translate here. We are in 2005. We are in 2006. And for this symbol, I prefer always to align it with the instruction. So that shows me this instruction, if it's true, all the block under it is going to be executed if that instruction is true. Another thing I do usually is I put some space just to make it more readable. If year equal 2005, show on the standard output on the screen, we are in 2005. Else, if we're not in 2005, but we're in here 2006, show on the screen we are in 2006. Same thing, my block finish here, else if we're not into, if my user do not enter 2005 or 2006, I'm gonna tell him, sorry, I have no information about that here. So I just tell the user that we don't have any information about this year, the year he was looking for. So this is the end of our program. It's a simple program. Keep in mind that every time we do something in computing technology, computer science, it's that we have to collect an information. It's always like that. You have to collect an information first. Because the computer, the main purpose of it is to process information. If we have to process information, we have to gather an information. And when we process an information, it doesn't make sense to destroy the result after. Most of the time, we have to do something with the result. We have to save it in a disk for a future use, or we're going to print a report on the screen to tell the user the result of the process. So here is the gathering of the information. We said to the user, what is your ear? The user is gonna give us the information. This is the process of the information. If else, this is the process. And the print here is to print something to the user to tell him, okay, I process what I ask you for, and here is the result of that. If the user say 2005, let's say we are in 2005. If he say 2006, we're gonna say we are in 2006. And then if he provide us something else, we're gonna say, I'm sorry, I don't know, I have no information about that. Just to tell you here, we don't have no format for printf, but we have one for scanf. The percent, it begins or tells my format begin here. 4, it's the number of character I'm looking to receive, and D stand for integer, a decimal number. Okay, so we are waiting for 4-digit decimal number. 4-digit, in fact, it's a maximum. We may have 0, 1, 2, 3, doesn't matter. And then when we got that, we're gonna process. Okay, so let's compile that. To compile, you said GCC, the GNU C compiler. Exercise number 1. My object file or my binary is gonna be example number 1 without the .c. So .c is my source code, and without the .c, it's my executable code. So if I try to execute that, it says, okay, what is the year? I'm going to say 2005. So we are in 2005. That's good. My program worked really fine. But this year here, I'm going to say 2006. We are in 2006, so that's great. That's great. And if I said 60 or 768, it says, sorry, I have no information about this here. So that program worked fine. But now you can understand, and it's more readable. Just let me make it even more readable. So this is my first program. I have my main function. I have an unsigned. I'm waiting for an unsigned. In fact, what this stands for, unsigned int here, when you compile a program in C, so keep in mind that the memory is having a segmentation, because there is a lot of program running at the same time in a computer. Every program is going to be assigned a segment of the memory, and in that segment of the memory, your program, you decide to make a variable called year. The way it works, it's a byte or a integer, it means 2 bytes, is going to, or 4 bytes sometimes, depending on the compiler and the environment, 32 bits or 64 bits and things like that. But keep in mind that a portion of the memory, just enough to handle a integer, is reserved, and you name it here. Every time you refer to here, it means that you refer to that memory space allowed to you to put a integer in that memory. So when we will ask the user enter here, the user is going to type on his keyboard a number, and we're going to put that number in that memory named here. So the ampersand here means the address where here is pointing to. So scanf is going to read something from the keyboard and is going to put that value at that little location reserved for you to remember a number. And then you look into that memory to see it, and you compare, is the number in the memory is equal to 2005. If it is, it's going to print we are in 2005. If it's not, it's going to check if that number in that memory represented by here is it equal to 2006. If it is, we're going to print we are in 2006. If it's none of the above, we're going to just print I have no information about that here. So because it's your first program, I give you a lot of details on it. For the next example, I might be faster on that, but because it's your first one, I'm a little bit more, give you more details. And by the way, when you do a if, a for, a while, something like that, instruction under this, if you have only one instruction to do, you don't need to specify a block of instruction. So you don't need that. When you need this, it's because you have more than one instruction. You have two instruction, you're gonna need that. You have 700 instruction, you're gonna need that. The only time you don't need it, it's because you have only one instruction to do, if it's true or if it's false. So we don't really need it. So the code is shorter like this. So let's try just to make sure our code still working fine. I recompile the code. I execute the code. Type in 45. Type in 2005 and type in 2006. So the code worked fine. And this is the first example. I hope you now have an idea what C program is, a little bit what's the if statement, what's going on when you have a number in the memory. I hope that it's good information from you and you understand well. Let's go with example number 2 now. Example number 2, it's one-dimension array. We can also call that a vector, or one-dimension array, or a array of one dimension. The way it works, I'm gonna go again with my spaces and make it more readable. This is another thing. The same student I told you earlier, the guy in Benin, he have this and he tried to understand, but it's hard to understand when it's written like that. I can't understand why examples are written like that in a book, or why a teacher can provide information, no indentation or things like that. So let me indent that properly, and I'm going to explain that to you. When I say properly, in fact, I mean my preferred way. You can indent another way if you want, as long as you make it readable for you and understandable. It's not a big modification, but quite good view the way I like to understand my code. So we still include the standard input-output library, or header file, I should say. When it handed by .h in C, it's a header file. So the standard std input-output, stdio, It's one of, we include that every time. It's just have the normal function to do basic input output. So remember in the previous example, we have here, it's a integer or unsigned integer. I'm going to show that later on another video about signed and unsigned. That's going to be for another day. Instead of here and only one location, we name that memory space T, and we reserve 5 integer in a row for that. When you want to access Harry like that, you access it by his name and a sequence. When you have 5, all the time in C the sequence start at 0, so it means 0, 1, 2, 3, 4. So at that space, sequence 0, I'm going to put the number 1. In that T, the T memory, the memory location that we call T, but sequence 1, the second one, it's 1, we put a 2. Okay, let me put the same numbers so that we won't confuse, or I'm going to put random numbers. 34, 38, 42, 55, and 77, or or 12. Okay. Just for the understanding, because maybe the 1 and the 0 it's confusing because of these numbers are almost the same. Let's start over. T, it's the name we allow to access our memory. So we reserve 5 integer in the memory. Those 5 integer are in a row. And the first one is T0. This is my first one. I'm going to put the number 34 in that space location. So you remember some eggs on the first content. Instead of putting an egg, you put 34 in it. So T1 means the second egg container or memory container. You're going to put 38. On the next one, you're going to put 42, 55, and 12 on the last one. But remember, the last one is the container number 4, because container number begin at 0, 1, 2, 3, 4. This is why we have 5. We have 0, 1, 2, 3, and we have 4. So we need 5. The way to access it, 0, 2, 4. It's important. I understand I say that many times. I'm completely aware of it, but it's important for you to understand that. Really important. Start at 0 until 4. This is my 5. And I'm going to change that name. By the way, when you put in C, it's a convention, uppercase name are reserved, not really reserved, but programmers always do that. It's a convention, it's a best practices to reserve the uppercase for constant number. Here it's a variable, it's not a constant. I'm going to show you that in my third example, how to define a constant. Okay, so because it's a table, I'm going to call it table. Why name it T? It doesn't really, it's hard to remember. If we have a big code with 4,000 lines, and we have many variables, call it A, B, C, D, E, you won't remember what C was reserved for. But if you put significant name, table, you remember it's your table. So it could be employees or it could be eggs. So it could be eggs. It depends on what software you're doing. So let's call it table, because I'm doing a demonstration for an array, or I call it array. I said table because in French we say table, but in English we say array most of the time. So I'm gonna call it my array. This is my array. I have 5 digits. My second one, it's just to count. A variable I'm going to use to count something. I want to count from 0 to 4 to display something. I need to count something. You can put spaces again, just to make the code more readable, especially for beginner. I know experimented user may say, I can read it, but when you're new and you begin, it's most of the time easier to read a code with spaces and well indentation, things like that. And then we have our printf. If you remember, it's to show information on the screen, and sometimes we're going to put a format. In our case, we put a format here, and \n, it's a new line or a line feed. That means when you print something on the screen, put the cursor at the beginning of the next arrow, of the next row. Sorry. So this is the way to move the cursor after we print something on the screen. %d, it's my format. So when I'm going to use array and 0, because my counter starts at 0, the first time I'm gonna go in the loop is going to print array, the container number 0. So I'm going to see 34 on my screen. And then the counter will be post incremented, is going to be 2. Sorry, after 0 it's 1. So array container number 1 is going to print on my screen. So I expect to receive 38, and so on and so on. There is one little mistake here, the semicolon here. This is a big mistake because the code will work. And when the student sent me the code, the semicolon was there, and he was trying to understand. I'm expecting result 0, 1, 2, 3, 4, or 38, 34, 34, 38, 42, 55, 12. I'm receiving something else. What's going on? Why? So I'm going to compile it that way, and I'm going to fix that error after. Just to explain you what is that error and what we're going to receive. So I compile this one, same compiler. Example number 2, I'm going to name my binary example number 2. I execute the code and I receive 32,765. So here is the reason why. Because of that semicolon, the code executes the for loop without any instructions. There is no instruction in the loop. Just because of these, because instruction should be right after or on the next line, but because I put that, there is no instruction. So what the program do is say, okay, counter equals 0. If counter is lower than 5, this is the case, continue the loop. So there is no instruction to do. So it's going to increase counter to 1. 1 is still lower than 5, so counter continue. And then 2, 3, 4, counter continue. The counter is incremented to 5. Is 5 is lower than 5? No, 5 is not lower than 5, it's equal. So because it's false now, the loop end and counter equal 5. So it's going to print array, but the sequence number 5. The sequence number 5, remember, it starts at 0 and at 4. So array, the content number 5, or if you remember the hex, You reserve 5 content, you put 34, 38, 42, 55, and 12. But the next content, it's not one of yours. It's another one. You don't know what's in that part of the memory. You never reserved it. So now we saw the number in that memory was 32,700 something. So you just print something that was not your array, but you are outside of your array. So when you made that kind of mistakes, you play somewhere in the memory that you did not reserve. And sometimes, because the way the kernel is working, if it's not a memory you reserve with that name, array, but maybe your program is allowed to read in that memory section. Because if you're not allowed to read in that memory section, you're going to receive a message like segmentation fault, core dump. Sometimes it happens like that. That means that you have a segmentation and you did not respect to play in that memory segment. If you try to play in another segment of the memory, it's a fault. If I'm looking, this is a Linux command to show all the process running on the machine. So if you see, I have Firefox running right now. So that means Firefox is in memory somewhere. So when I launch my program, I may reserve a segmentation of the memory for me, but maybe I want to play in the Firefox memory. Maybe I'm going to scan all the memory to see if I can find password that Firefox have in memory, and maybe I'm going to spy those passwords. So for that reason, for security reason, you are allowed into a memory segmentation, and you have to properly manage your memory, because you are going to have a segmentation fault or a random number. Like here, we have random information that we never expect to receive. And we have a number that we don't understand. So this is why I'm going to fix this error. Because I removed the semicolon now, the for is going to do this line every time on every iteration of the loop. So it's going to do it when counter is 0. It's going to check if the counter is lower than 5. Now it's no longer 0, it's 1. It's going to do it with 1, and so on for 2, 3, 4. So now let's try if we have a better expectation, or what we expect before. We're going to have it right now. So example number 2, I have 34, 38, 42, 55, and 12. So now our program is running. We know what our code do. We manage properly our memory. We understand it, and we play with it properly. So when you do this like that, you should have what you are expecting to receive. So that's all for this code. I'm doing a last example with the 2-dimension array. And that was part of my student question. The Benin guy, he was asking me, I have difficulty to understand 1-dimension array and multi-dimension array. Could you give me an example? And because I talked to you about that Benin guy, but I saw that kind of question really often on social network, and I'm pretty sure if you are a beginner in C programming or any kind of programming, you may have the same kind of questions. So this is, I'm going to start from my example number 2. I'm doing a copy of this example, and I call it example number 3. So now I have example number 1, 2, and 3. I'm going to VI example number 3. Let's imagine that you receive a call from a business across the street they heard about you and they said, okay, I hear that you are a programmer, and my accountant guy is doing payroll every week. He do that manually. It takes a long time. Can you do a program for us? So my account man is going to do that easier. You say, okay, I'm gonna do a program for you. I will define constant for that. I'm gonna define max rows. That will be the maximum row I will have in my two-dimension array. This time I will call it array employees. This is my array of employees because I'm doing a program for the account guy across the street. Okay. The number of row will be 5 and the number of column 3. And we're going to use float for that because we will have, you remember int? It's a number like 1, 2, 3, 4. Float, it's a floating point. It's a number like 1.75 or 1.33. It's numbers like that. We call it a float. And we will have a counter also. Now I will say my array of employees 0. So line 0, column 0. That will be the employee number. Employee number 3456. Line 0, column 1. That will be the hourly rate I pay my employee. I pay 12 cents per hour. Number 2, that will be the number of hours my employee work per week. He worked 40 hours a week. So this is why I choose that in my mind. You can do the program the way you want. You can put the number of column you want. The number of row should be equal to the number of employees in that company. I will define my second employees. My second employees will be row number 1. The employee number will be 3457. He have a paycheck of $10 per hour. He is also working 40 hours a week. My third employee, for sure, when you do a program like that, you don't put hard code salary and things like that in your code. Most of the time you put that in a database, and then your code is going to read the database and do things like that. But because it's only our third example and we're a beginner, I'm doing it that way. And when we're going to be intermediate, I will show you how to put this in the database and grab this information or fetch the information from the database with your program. But now we are at first level. We're going to do it like that. So this is my employee number 3. His employee number, because it's the manager, he's working, having a bigger salary, and he's working more hours. And my last employee, although I say 5, so that's going to be my the fourth one. Employee number This is having 10, 11 per hour. Is working 38 hours a week. And my last employee number 4, or not number 4, but employee number 3600. But this is my 5th one. 5th means 0 to 4, so it's container number 4 in the memory. And we still have the 3 same rows for him. And is working only 10 hours a week because it's a part-time employee. And I pay it $8.33. So this is my 2-dimension array. And here, instead of putting 5 and 3, this is the reason why I define constant. It's to use those constant like this. So my table of 2 arrows that I will use for my employees to calculate the paycheck at the end of the week is going to be max arrow, or 5, and maximum of columns. So in our case, it's 3. And we do a for loop. We're gonna start at 0 because our container for the line start at 0, and we're gonna end at max rows. If we change max rows to 6 later, because there is a new employee, we have only one place to change it. So 6 will be used here, and 6 will be used here. We have only one place. This is a good way to use a constant for. And at the end, C++. And now because we have more than one instruction, because I will put more than one, we use that to identify begin and end of a block of instruction. First, I'm going to print my array of employees, row number, the counter, and the column 0 to have the employee number ID. I will not put a \n because I don't want to get on the next line right now. Next, I will put employee 1. So the same employee, but the column number 1. Column number 1, if you remember, it's the hourly rate. Hourly rate multiplied by a employees after 2. So a paycheck, it's the hourly rate you contract with your employer multiplied by the number of hours that you work during that week. So for that employee, paycheck will be, and here we're going to put F, because now we are not interpreting that memory location here, or the number represented by the multiplication of those 2 memory locations by a float. Is going to give us a float. Same thing here, it's a float. I forget about this one, but it's a float. And then I'm going to print only a \n to put the cursor back to the next line, and we are going to print our next employee paycheck. That's not perfect, but let's run this code and see what is not perfect in that code. Okay, we have an error compiling this. Undeclared A employees. Maybe I just made a small mistake about the names. I call it A employees, EES. Do I write this properly everywhere? Oh, here. I put E and I should put A, employees. Try to compile again. Now it's fine. I have my employee number here, and because it's a float, it's showing as a float, .00, and here it's showing as a float also. The problem is when you program something, you are the expert, you are the programmer. People expect from you information technology. Information is keeping information somewhere. You gather information, you process, and you know how to show a result to an account people. Account people don't want to see .000. It's not human readable, and like this, there's no alignment. And why that amount of precision? We are talking about money. We should only have 2 digits after the dot. So you, as a programmer, you have to know that, and you have to fix the output. The output is not a good way to show information like that. Let's get back to the code, and I'm going to change the format. We can put 0.0. 0.0 means reserve 0 space for the next number. Reserving 0 space means if there is only 2 numbers, show 2 numbers. If there is 5, show 5. And after the dot, put nothing after the dot. We need only the entire number. We don't need the fraction number for this specific column 0, the employee number. For this one, we're going to reserve 7 position for the number. The whole number, we reserve 7 position. In that 7 position, you put the number, and you're going to give us 2 digit maximum. So running the code like this, we're going to see what's happened now. Now we have the employee ID without the .0, and we have a better view of the amount of money with only 2 digits because it's an amount of money. Let's stop at 2 digits, and that's all. This is the way to use 2-dimension array. So today we saw a first program where we can just ask the user a number for a year, and we say yes it is or no. You are here to 2005 or 2006. It doesn't matter. Our second program was array 1 dimension, quite simple with a couple of numbers and show those numbers. And our second array with float, we have an accountant, a business across the street is asking you to do something for the company, and you do a good program. So now the account will be able to do it faster because they have 500 employees. It could be helpful for them. Thank you very much for your time, for viewing that video. I'm going to make other videos soon. I'm going to explain really more about C because we are only in an introduction here, but I'm going to give you really more information. I'm going to put intermediate, advanced, until you're going to be a guru of C programming under Linux. Thank you very much.